Hi folks, this is Nat, and this is going to be a video lesson on graphing equations with two variables on a coordinate plane. So we've talked about equations before, and if you have an equation that has more than one variable, in this case 2 is what we'll be working with, you actually end up in a scenario where it has an infinite possible combination of solutions. And I can show you what I mean by that real fast. Just a simple one, like if we start with 2x equals y, well, there's a lot of scenarios that would make this a true statement. If x, for example, were to equal 2, this would be true if y equaled 4, because 2 times 2 does equal 4. Or if x was to equal -4, 2 times -4 would equal -8. So if y was -8, it would be true. And you can kind of see how we'd quickly end up with an infinite number of possible solutions that would make this a true statement. And so what we're going to be looking at here today is how we actually graph all those solutions, which is actually a good way to represent all the possible solutions for a two-variable equation. So let's get started. So we'll be graphing on a coordinate plane. And as you start to set up your coordinate plane, some things are going to be pretty typical. X is going to go on the horizontal axis, y is going to go on the vertical axis. And then we're going to need to number our two axes with two different scales, or the same scale potentially, and make all those good scaling decisions that we typically do. One thing to remember is that 0 is always the corner. So 0 in this case is the intersection of the two axes. It's almost like we have taken two number lines and turned one of them vertical and lined them up on their 0 marks. From there, I make all the same decisions I normally would with scaling. I need to decide, what am I going to count by? What am I going to space by? A lot of the times people decide to count and space by just like typical things like ones. So for example, I might count by ones on my x-axis. And in this case, I'm doing it skipping 2 spaces every time. 0 is already on there, so I didn't include it. And then when I go onto the other side of the x-axis, I'm getting into the negative values here. So it goes -1, -2, -3. A lot of the times, you'll want to scale your y-axis the same way. Sometimes you won't. It doesn't really matter if you do or you don't, provided when you scale your y-axis, you do it consistently for the whole axis. So I might, for example, continue to skip 2 spaces, but now count by 2s instead of by 1s, and do 2, 4, 6, and -2, -4, -6. And once we have our graph scaled, we'll be able to plot points onto it. And points are going to come in the form of coordinates that might look like this, something like 2, 4. When you see a coordinate like that, typically it means x value first, y value second. That's the standard way of writing it. So this coordinate would have an x value of 2 and a y value of 4. And I actually messed that up already. An x value of 2 is going to be here on the x-axis, and a y value of 4 is going to be here. And we plot the point at the intersection of those two things. So 2, 4. 2, 4 is going to end up being right here. You could also see points with negative values. Let's say we had -3, 2. -3 on the x-axis, x comes first, is going to be here. 2 on the y-axis is here. And I'd plot that point at their intersection, there. And that's basically all there is to it. That's what we'll be using to plot points that we calculate with our equations. When it comes to graphing an equation, all we really have to do is gather a set of points that we can put on. And for today's purposes, let's say we'll always do 3 points. So I'm going to start by looking at the equation. I'm actually going to rewrite this. Y equals 2x minus 1. And let's go a little closer. Y equals 2x minus 1. An easy way to plot this equation on our graph is to collect some coordinates by inputting some random x and y values. So I might make a t-chart here with an x value and its corresponding y value on the side. And from here I might just make up some x values. You might have a tendency to choose positive values, but it's a good habit to get into to include maybe some negative values as well. I might actually pick 5, -2 through +2. So if we go to our equation, it's 2 times x minus 1. So if x is -2, 2 times -2 is -4, minus another 1 is -5. That would be my y value over here. -1, 2 times -1 is -2, minus 1 is -3. And I'd keep going, filling in all my values. 0 is going to end up being -1, 1 is going to end up being 3, and, sorry, that's not right, 1 is going to end up being 1, and 2 is going to end up being 3. Okay. So now I have functionally a set of coordinates. -2, -5, -1, -3, 0, -1, 1, 1, 2, 3. X values and Y values that now need to go onto this coordinate plane. So, first thing is to scale it. And I'll take a second to look at my data and think about what I'd like that scale to be. Well, all my data kind of stays between the biggest outlier is this -5, so I want to make sure I can get to -5 on the y-axis. So maybe I'll count by ones, just so I get down to that -5. So here's -1, -2, -3, -4, -5, -6. And I do the top the same way, 1, 2, 3, 4. It's probably good enough. And then I've got pretty standard 2 to -2 on my x-axis, and I'm going to scale that one the same way. -3, -2, -1, 0 at the corner, then 1, 2, 3. It's good enough. Now I'm ready to put my points on. Points I'm going to just represent with a dot. So -2, -5. That's -2 on the x over here, and then way down to -5 over here. So here's where I'm going to put it. Some people like to connect those lines up to help them see it, but I don't want to keep those once the graph gets going. So I'd erase them if I put them in. Then we go -1, -3, same thing. That's going to live right here. 0, -1, here. 1, 1, here. And 2, 3, here. And my last step is going to be to connect a line through each of those. And that actually is the graph of my equation. I put arrows on the end to show that it goes infinitely in both directions, because I could, again, come up with an infinite number of coordinates. I've picked these 5, but I could go on forever and ever and never actually do all the values of x and y that are possible. And that's basically it. That's how you graph an equation. I'll show you another one really quickly. Probably not going to spend quite as much time on it. Here's one with y equals 1/3 x minus 2. As I come up with my x and my y values, in this case I see that I'm going to be dividing by 3 to whatever x is, so I might make my life easy and pick multiples of 3. So like I might say I want x to be -3, 0, and 3, so that when I divide I get a whole number. And my y values in that case are going to be -1 minus 2 is -3, 0 minus 2 is -2, and 3 times 1/3 is 1 minus 2 is -1. And again, I can graph those coordinates on my plane once I put in a scale. Nothing passes 3, so I'll probably just do ones again. I'll put my points on. -3, -3 is down here. 0, -2 gets me here. And 3, -1 is here. Last step is to connect those up into a line. It's not the best line, but that's the basic idea. The last thing I want to show you before you do your practice problems is we can actually graph equations that don't have that kind of super easy setup where y is by itself on one side. We can also graph equations that don't necessarily have an x and a y. Here I've got an m and a w. In this scenario, there's nothing to really change except I want to now shift instead of x's and y's. I need an m and a w, and it doesn't matter which axis you choose for which one. I've put my w as my x, so I'll probably do w's first for my coordinates, just so I don't get confused, and m second. Same deal as before, I'm just going to pick some values. I might actually reverse this and pick m's first. So maybe I'll pick -2, 0, and 2 as my m values. And it's very similar, except I actually have to solve the equation. So if 3 times -2 minus w equals 18, 3 times -2 minus w equals 18, that means -6 minus w has to equal 18. And in this case, what that means is that w is actually going to have to be -24, I think. Yeah, -24. 0, same deal. I'll just replace it. And we could go through the process of actually solving these if we needed to, and I'm just trying to speed this up. 3 times 0 is 0, so 0 minus w is 18. And that's going to be -18 for w. And then 2 times 3 for my end is going to be 6, and 6 minus w equals 18. So in this case, it's going to be minus -12. This is not an ideal scenario in terms of explaining it, just because these were more complicated calculations, but if you do it, you end up with the exact same scenario. Now I just have to plot these points. The big difference is that my w is all in these big negative numbers, so maybe I want to scale my w instead of by ones, maybe I'll scale by sixes. So 0, 6, 12, 18, 24, these are all negatives I should have included. And same thing on the other side, since you don't ever scale the same axis in two different ways. When I go to the y-axis, this is a lot smaller, so maybe this one I'm actually going to scale by 1 still. So 1, 2, -1, -2. And I can graph it. So my first coordinate is -24, -2, so that's going to be here. My second is -18, 0, here. And my last one is -12, 2, which is going to be here, kind of in the middle of what I've written. And that's pretty much it. I'm going to connect those up with a line the same way I've done before. And I've graphed that equation. Alrighty. So that pretty much covers it as examples. Your last job here is going to be to graph these 3 equations. Make sure you use graph paper, set up good scales, do all that. Good luck.